Hey guys, Ragwan at Woodstopia 2024, introducing the all-new CRWorks Kiwi. This is a super awesome frame, and I'm going to go ahead and walk you through the build process for both 6 and 5 mil arm versions, as well as an arm swap. Let's head back to the workbench and I'll show you how it's done. So we'll go to the bench. This is a fully assembled Kiwi. This is the end product of what we're looking for here. Couple things that differentiate this frame from others will be the optional 6mm arms. So this frame has 3 arm options. You can of course have 5mm arms. That'll be your lightest build weight, paired with these 6mm hex standoffs and all aluminum screws on the bottom. You can go ahead and option for 6mm arms, and that's what we'll be building on the bench now and what I've got here in my hands. This is a big step up in both stiffness and overall durability. Great for all-around racing, puts you at about 55 grams frame weight, including your stack screws with aluminum hardware. And then you can go ahead and option for the long arms, and that'll allow you some more clear airflow to your props. Or if you want to go ahead and use the mid-mount and fly with your battery mounted on top, you can do that with the longer arms as well. Other differentiators on this frame, of course, is the M4 hardware, and that allows you to get away with aluminum arm screws without having to worry about bending or stripping them out. It's a great option to save some weight while still maintaining a lot of strength in the core of this frame. You've also got 2 options for standoffs. So this is the 6mm hex standoff, but there's also a 7mm round standoff. It's a difference about 2 grams of weight. The 7mm round standoffs will provide greater strength, and would recommend pairing those with some steel arm screws, which is what we're going to be using in this build, but we'll be using the lighter standoffs. The top plate is a full 42mm wide, so that'll give full protection for either a 60 amp Foxy Reaper ESC, or if you want to use the slim version, you can rotate that full 90 degrees and it'll still provide protection for your ESC and just about any kind of crash you'll get yourself into. The main purpose of this frame is really to provide ultimate electronics protection no matter the flying conditions, be it flying in the woods and trees or on conduit gates at top speed. This will provide you the maximum protection to your electronics without having to worry about bending standoffs, bending arm screws, so that you can fly with utmost confidence as fast as you possibly can. Let's go ahead and get into the actual build here. So here's everything that you're going to need to build the Kiwi frame. You're going to have your bottom plate, and that is a 2.5mm thick bottom plate with countersunk for your M4 arm screws and your M3 stack screws. You'll have your 2mm thick T700 mid plate. All carbon on this frame is T700. That'll have your 4 stack screw press nuts, so no need to add additional nuts to hold your stack screws in place. It's built into the frame. This is your 42mm wide T700 2mm thick top plate, provide maximum electronics protection and crashes. And here we've got 4 of the 6mm arm variant. So this is the short arm version. It's got 3 motor screws for each arm, your M4 arm screw that mounts, and then this will meet in the center, so there's no need to pocket the end of the arm. That reduces the chance of you splitting your arms down the middle, as is common with a lot of 5-inch racing frames. It'll give you a lot more durability in the arm, make it last a lot longer as you're crashing and flying throughout the day. And so towards the end of the day, where typical 5-inch frame will start to get those noodle arms, this frame will stay resilient, whatever the beating you put it through. You've got your M4 standoffs, so in this case they'll be the 6mm hex variant. Your 30mm long stack screws. The frame will come with 7075 aluminum screws, however shown here are a grade 10.9 steel. In this version we're going to be building the 16mm long M4 grade 12.9 steel arm screws. That'll give you the most durability in your arm screws. However, in testing, the aluminum screws have been perfectly fine and haven't had any damage to them, even in full speed crashes into trees. You'll have your 70-75 aluminum top plate screws. You'll source these separately. These will be your camera screws for mounting the camera. And then we have our assortment of 3D prints. So this is the camera mount. The camera mount will use the 2 screws to mount it. And there's multiple different options for camera angles in different cameras. This particular mount is for the Nano 90 camera with a glass lens. However, all the Nano 90 with glass lens camera mounts will also fit your analog Foxeer Predator 5 Nano camera. So we'll install that as well. You've got your shark fin, which will both help internal and protect that top plate in really hard crashes. You've got your press-in antenna mount for your video antenna. You've got your folding style RX antenna mount for Tracer, Ghost, or ELRS. And then you've got your anti-wiggle piece, and this is a shock absorbing piece in the middle of the frame. It gets loaded under compression when we tension up the arm screws at the end of the assembly process. Step 1 is going to be to grab your bottom plate. Now we're going to use this anti-wiggle piece here, and we're going to assemble it so that we press this larger side into the bottom plate. You'll press that all the way down so that the little fingers are pointing to the front and back, and then left and right of the frame. This frame is built entirely symmetrically, so there is no front and back until you put your camera and your antennas on it. The top plate will also dictate front and back. The larger notch is the back, the smaller notch is the front. Next step, you'll take your mid plate. The only thing to note on the mid plate is that you've got one side with a rounded cutout and one side with a flat. The flat goes front and back, and your standoff or your press nuts go to the top. So you'll just lightly press that till the insert is at the top. You'll see there's a gap there. For 5mm arms, you don't need the gap. For 6mm thick arms, you'll want to leave that gap in place. The next step will be to install our 4 stack screws. So you'll just thread these through the bottom, get them started. You're going to thread them all the way through, like so. And then I find once you get them started, they are very long. Just grab the top, spin them through from the top. And you again, leave them nice and loose. You want to maintain that gap in the top of the anti-wiggle piece. The anti-wiggle piece is the same for both 5mm thick and 6mm thick arms. So if you choose, you can have both arm variants and swap them in a matter of minutes. If you want to maybe say build a few grams lighter for race day and practice on 6mm arms without having 2 separate quads. So now we've got all 4 of our stack screws installed. We're going to install our first arm. I'm going to recommend you start in this top right corner. You'll take your first arm. These arms are entirely symmetrical, so it doesn't matter which arm you grab or what orientation. The main thing you'll want to note is that this notch here, that is where your stack screw goes. Of course, where my thumb is, that hole, that is for your arm. You'll insert it into place. There's the view from the side. There's the view from the front. Go ahead and line your screw up, your screw holes up, and you will have to apply some pressure. As more arms are inserted, that amount of pressure will increase. Go ahead and just start it real quick. And then these are M4 screws, so the countersunk screws will require a 2.5mm driver. You'll go ahead and insert that, make sure you get it all the way seated, and then thread your arm into, or thread your screw into your arm. The tolerancing on these armholes is very tight, so it will require some threading. And that'll be both for all arm variants. Leave yourself just a little bit of room. Don't tighten that all the way. The last step in the build process will be to tighten the arm screws all the way down. And doing so will put the top plate and bottom plate under tension while also compressing all 4 arms together. If you tighten the arm screws too early, you'll have a very difficult time getting all 4 of them into place. So go ahead and save yourself the effort. Leave them just a little bit loose. You'll have your opportunity to tighten them next. Second one started. You'll want to build both the front and back together. Again, starting on the right side, moving to the left side. You can do it the other way, however, you'll be tensioning against the wiggle plate or the wiggle piece, and it doesn't always like that. Again, leave yourself just a little bit of thread. We'll go ahead and flip this around. Again, the right side. Take your arm, insert it into place, flip that around, insert your arm screw. And the last one, this one may require the most amount of force to center it, as all the other arms are currently in place. But go ahead and carefully wiggle it into place. You want to make sure that you can see the end of all sections of the wiggle piece. Get your screw hole lined up. Drop your last arm screw into place. And thread it, leaving just a little bit left, not fully tensioned at the end. Like so. Next step is going to be to install all 4 of your standoffs. These will just thread right into your arm screw. Cinch it right down there. These can be finger tight for now. They will get tension at the very end. Okay, now your frame is ready to install your electronics. The first thing we'll want to do is grab over here. You've got a set of spacers. So these ones that are taller and have a larger lip on them, they are your ESC spacers. So they provide the correct stack spacing from your middle plate to the bottom of your ESC to slide a battery strap through. You'll go ahead and press all 4 of these down onto your stack screws, like so. They are tight, but that will keep them in place. I find it's easiest just to use your fingernails on either side of the stack screw with the frame flat. Okay, now that those 4 are installed, we'll go ahead and install our RX antenna mount. So this is using the folding style CRWorks RX antenna holder. You'll insert your antenna. There is a location where it will sit naturally, and the antenna will come out the side. And then you'll press that onto whichever side you choose to be the back of your frame. We'll just have that antenna come out the side for now, like so. So we'll flip it around. There's the back and the front. Now we'll go ahead and do the camera installation. So for this build, I'm going to use the Foxeer Predator analog camera, and this will be the Nano 90 camera mount with the glass lens option. It'll also be used for the Foxeer Predator camera. Go ahead and push the camera in. You're going to use a 1.5 millimeter driver with the screws that came with your camera, and snug that down, 1 on each side. Once you do so, it'll just press into place right there. Now I'm going to go ahead and grab a stack. This is just to demonstrate how we're going to do the flight controller and ESC spacers. This happens to be a hobby wing stack, however it'll work with the Fox or 60 amp. Just about any traditional style ESC will fit into this frame. There is going to be a DX or STL file that you can print that'll give you the spacing of the standoffs, just so you can confirm if you're contemplating an ESC for this frame. The way that you'll install this is you'll just press it flat down onto your standoffs, and we're going to take our 4 ES or flight controller spacers. Those will press down flat just the same way that we did the ESC spacers. Orientation is not important on this one, so either the top or bottom side and the orientation it printed will be fine. Whereas on the ESC spacer, the lip needed to be up. With all 4 of those pressed in, you'll take your flight controller, you'll press it down, and then from here, you can go ahead and install your flight controller nuts. So 4 of those will go on top, and you'll put your VTX board on top of that. So the completed build will look something like this. So here you can see you've got your 4, now they're black on this build. Come to this side here. You've got ESC, flight controller, threaded nuts, and then your VTX board floats on top of that. It's held down both by the top plate and the antennas for the VTX, and the camera cable will route. And that'll hold it in place with plenty of room to make sure it's got solid airflow and will not be damaged in a hard crash. Coming back to the current build, we'll go ahead and install both of the antenna and the antenna mount for your video transmitter. That'll just press right in. And then right on top. I'd recommend doing this after you've installed your VTX board into your frame. And of course you can snap that into location. For the top plate, you're going to have your shark fin and your top plate. The holes on the shark fin are undersized. That is intentionally so, and it will prevent you from having your top plate screw pull out through the arm. So I would recommend put the screw into your driver, your 3mm hex driver, push it into place, and then thread it the rest of the way on. Depending on your print settings, this may be easier or more difficult to do. If you're having difficulty, you can take your 3mm hex driver, insert it, widen the hole, and then using your top plate screw, insert it into the shark fin, thread it all the way down, and now it's ready to be installed onto your top plate. Take your top plate, line up those holes, and then I would recommend taking a zip tie. You can apply a zip tie here, and that'll hold your shark fin, so in the event of a hard crash, maybe going in reverse through a gate, it'll keep it stuck down. Take your top plate, line up your top plate screws, and get the front 2 started. With those just started, you'll notice that your back screws may not entirely line up. That is normal. So that depends on how much tension you've applied to your arm screws here at the bottom. As this frame comes together, it puts the top plate and the bottom plate into tension and compresses the 4 arm screws together. If you've left your screws sufficiently loose, you'll be able to just pinch into place, start your top plate screw, come in. Make sure that you do this by hand. I would not recommend power tools to start them. We'll do the same on the last one. Make sure it's adequately lined up. Start slowly. Once you have all 4 started, go ahead and tighten your top plate screws down adequately tight. Go ahead and start here. Again, the undersizing on the shark fin holes will allow you to get that shark fin quite tight. Okay. With all 4 tight, we are on to the last step, which is to tighten your arm screws. Now that you've got all of these lined up, as you tighten the arm screws, it's going to force the arms into the center, into your TPU anti-wiggle piece. That'll apply the bottom plate under tension and the top plate under tension. If you do this step without the top plate installed, it will cause the standoffs at the front and the back to kind of spread open. You can use your fingers to realign those standoffs if you have to do work on the bottom or on the inside your electronics and you do not wish to loosen your arm screws. However, in the first assembly, just to make it a little bit easier, we left those loose. So now you're going to insert your 2.5mm driver in the bottom, your 3mm driver in the top, and the 3mm driver is just there to keep the standoff and the screw from rotating. Get that nice and tight. With these M4 screws, you do not need to worry about stripping even the aluminum arm screws. With all 4 arm screws tight, your frame assembly is now complete, and this thing is incredibly stiff for its weight. Now is a great time to add your optional battery pad. You'll remove the 3M sticky on the back and line it up with, I would recommend the 4 screws, pick either the bottom or top to start. Gently lay it in place and press it down. This will still give you access to your 2mm stack screws. If you need to remove an arm, you'll just back it off, half a turn. You'll take your 2.5mm driver, you'll insert it, you'll take your arm screw all the way out, and then from there, you can pull your arm all the way out of the quad, replace it, you'll do the reverse, just as we did in the installation. You'll insert your arm into place. Line it up, insert your M4 screw, and then take your 2mm driver and tighten that stack screw right back down. For battery pad or battery strap, you can go ahead and take any 16mm wide battery strap, even the thicker ones. Of course, inserting that with the Velcro side up, you'll push it all the way through. You may have to wiggle it slightly to get it started. So it comes out the other side. And then you can go ahead and cinch it down on your battery. just like that, you've built your first CRWorks Kiwi Frame. It's a fantastic option for general purpose flying or flying at the high end of performance. You can have build weights right down around that 50 gram, not including TPU, or more durable options up around the 55 gram to 60 gram weight category with 6mm arms. In all, it's a fantastically light frame with a lot of protection, even in the hardest of hits. Easy to maintain, and a nice, small, durable form factor. Happy racing!